Hello, my name is Brian Rojas, and today I'm presenting critical data storage for a Fintech organization. This to meet it with the compliance for SOC 2 Type 2 ISO 27001. In this presentation, I will go over the problem summary, the critical data storage needs, the AWS services, the infrastructure review, and a live demo, including the AWS live demo and the secure portal live demo, including the show and tell of the cloud arrival into the file storage. This to ensure that no sensitive data ever persists on the web server itself. Problem summary: the onboarding challenge to meet compliance requirements. My project was to build a cloud native solution to a specific problem. I designed a portal that acts as a secure portal. It authenticates the users, encrypts data in flight, and instantly offload to a secure storage. This to ensure that no sensitive data ever persists on the web service itself. This architecture was built specifically to align with SOC 2 Type 2 and ISO 27001 of compliance standards. Critical data storage need. The project will allow users to upload their personally identifiable information such as bank statements, social security numbers, and credit card numbers. This is required as the customer documentation is needed to be onboarded into the platform. Without that information, the company cannot create the Portani profile, neither can use the portal to activate the first profile, therefore the need for this critical storage. The employee will receive the PII file and will set up an account on the administrator portal for the client to start using the platform. Confirmation on the portal confirms that the client has received the data and the onboarding process is ready to be started. AWS services implemented into the secure web portal. All files uploaded into the portal are scanned for sensitive data and threats. This stops with any malicious documents or applications from being uploaded into the web portal. The tools that we use or the services that we have enabled in AWS Console was the VPC to build a virtual private cloud with a public and private subnets to isolate the network traffic. We use an EC2 instance that uses a Linux server located in US East 2 to set as the web server. We also use an S3 bucket that was created to provide object encrypted storage for personally identifiable information. We also use IAM, roles added, granted secure server access permissions to talk to the storage services. We also use Route 53. The domain was used to create the traffic into the web page. All of the traffic was set into www.rojasbrian.org. We also use EFS, which allows a scalable network file sharing while utilizing the required space for the S3 storage. We have used also Amazon Macy, used to scan for sensitive data added to the S3 bucket and all the data provided by the client. And we will use for threat detection guard duty. This will perform intelligent threat detection for all AWS services used in this hosted infrastructure. AWS architecture for the FinTech Secure Upload Portal. The data portal will be where all clients upload their personally identifiable information into the AWS services. We have our VPC, which holds our entire project as our secure network container. It obtains a public and private subnets, an internet gateway, and route tables. This will begin with the data portal arriving to rojasbrian.org, and then it will get into the internet gateway to be separated into the public subnet. This is then received by the EC2 web server running a Python application and hosting the website. We also have the S3 Simple Storage Service, which is a secure bucket where all the client's files, PDFs, or Excel will be stored. We have also used IAM to identify the role, which is FinTech S3 web role, that will be the EC2 permission to tap directly into the S3 without any hard-coded passwords. We are also using the elective file system, which is the shared network drive mounted into the Linux server to have persistent storage and make sure that the storage, if it is required, it increases sizes. We have also used an elastic IP to make sure that the public IP, which is 18.116.15.99, ensures that the server never changes an address and is always available. We have also used Amazon Macy, is the security service scanning the S3 bucket for all sensitive data, which is personal identified information as credit cards and social security numbers. Guard Duty will be the threat detection service monitoring the account for any hackers or any malicious activity. Therefore, the portal will be set into the main website. Therefore, any data uploaded into the AWS cloud will be scanned with Amazon Guard Duty and Amazon Mason. One, to understand for threat detection, and two, to make sure that the data has any personally identifiable information. This doesn't get shared and is only accessible from the public subnet, and the private subnet will be only accessible to the infrastructure admins. Now, I'm going to do a full deep dive into the architecture and network design. First, I'm going to look into the VPC, which creates an isolated network boundary. In this case, we have instanced fintech-VPC, which is our VPC, fintech VPC. In this fintech VPC, we only have access to the fintech public and private subnets. We have two route tables that directly go into the public and then into the internet gateway. Therefore, it means that the public gateway is the only one that has connection into the internet. The private, instead, will hold all our secure storage and it is not accessible through the web. The web server only allows traffic on port 443, port 80, and port 22. I adopted the last privilege model here, which allows only the web server to accept traffic from port 433, port 80, and port 22. Now I'm going to go into the EC2. In EC2, my instance has been named EC2 Fintech Web Server. This web server contains a public IP, which is an elastic IP of 18.116.15.99. It also contains the setup of the web server, and it has the roles which only allow access from my instance. One, which is my port 22 TCP of my IP. It also allows port 80 for the website access and the port 2049 TCP for the FinTech Web Server Group for Macy and the security group FinTech Web on port 2049. This has the access for all Amazon Macy and the Amazon Guard Duty. Now I'm going to go into the IAM roles. In my IAM roles, I set up a user, which is user fintech, and I also enabled a role. In my role, I call it fintech S3 web role to provide access into the S3 bucket with full access to only that web role. I created this custom IAM role to directly be attached to the EC2 instance so that when Python script runs, it uses Boto3 to verify the server's identity. AWS also grants the server a token for the access of the S3 bucket, and it means that if a hacker can steal or steals my source codes, they will find zero credentials. Now I'm going to show my S3 bucket configuration. In my S3 bucket configuration, I have set the name of Fintech Data Intake Bill Rojas CSCI E90 on US East 2. This bucket has current downloads of client information that we have already uploaded to test the software. This allows any object to be uploaded and be shown and grabbed by the client or the infrastructure team to be able to be uploaded directly into the portal. I also created an EFS. This allows for the file system to be pointed directly into an S3 bucket, and it provides the engagement to reduce or increase the size, and it also provides the encryption for the EC3 and S3 buckets. Now I'm going to show the Route 53 configuration. In my sphere, I have a hosted zone of rojasbrian.org, which has been set up with records for www.rojasbrian.org as a status A for www and in the elastic IP of 18.116.16.99. My Nest configuration shows Amazon Macy. Amazon Macy is already encrypting our S3 bucket and is showing that the information is not publicly accessible. Now in Amazon Macy, this configuration is attached to the encryption of the S3 bucket and it reads all the servers, including the buckets, to make sure that the data that it has been updated is secure. Amazon Macy also identifies that all personally identifiable information is being seen or not seen. Therefore, it marks as sensitive or not sensitive when the automated discovery runs. My last part or the last services I used is Amazon Core Duty. It provides the scanning of the S3 bucket as well as the protection of the S3 that you can see here. The protection has been enabled for the S3 bucket, and I can also run scans directly into the EC2 instance. This provides the views and malware scans, making sure that there's no threat found on my instance. The S3 bucket is clean and the EC2 instance is clean. This also runs a summary on all the different credentials, including the findings of all the AWS infrastructure set in my account. Now I'm gonna go over my Python code to show the setup and zero trust security that I set up. We are using Boto 3 to show that is for Python. Now notice that the S3 bucket has no keys. Instead of the code, what I did is I set up an IAM role that is attached to the EC2 instance. That means that there's no hard-coded credentials that exist on my source code, eliminated the risk for any credential to be leaked. If you see now the upload is the upload handle that allows for the file ingestion. Now you can see app route. In the app route, this handles the file ingestions. What I'm trying to set here is that we use upload dash underscore file object to stream the data directly into the S3 bucket, which means that it never actually is written into the local hard drive, but it passes directly through memory through the secure storage in S3. Now I'm gonna go over the login and authentication. If you notice the login and authentication, it validates a JSON payload to the front end against our stored credentials. And only the username, user and password, which is Fintech and CSCI E90, are the only authorized success user and the only success message that can be allowed within my Python code. Now I'm going to go over the index HTML or our website. In the HTML, I divided it in two different views, which is one, the login dashboard, and the dashboard view. In the login view, I set up the display to make sure that we have a login container and a login website, and the dashboard view, which is the main interface. This code also combines an application from CSS to make sure that the website looks okay, and also provides the view of the questions that I set up on the web page for the compliance wrapper or the compliance side, which are the set of questions which has a block. Each of the block contains a set of answers of why we're using the SOC 2. You can see here that I combine a few of my knowledge on HTML, and I also use a little bit of AI to try to help me make sure that the website was seen good in CSS, right? We also have a few of the buckets in the backend, which allows me to set the password and a username, which are the login views, which I set the names and description, and I put the password that it links directly with my Python code, and it also links directly to the application on the web. Now I'm going to show the small JavaScript that it allows an interactive counter to understand how many times the button has been pressed for updates, and it will show the counter directly on the website. This helps on the recent uploads tab. With this, I have successfully gone over the main files, the app or Python file, the index HTML file, my JavaScript, and of course, my style CCS, which has been already included to the HTML for better setup. Now I'm gonna go over the finalized project. First thing is going to the website, and they will arrive into the Fintech security portal, meaning that all the clients will have a username and password that they will log in to make sure that nobody else which is not accepted has access to the portal. Here, they will put the password, they will click on secure login. Here, it will be taken to the secure data intake portal. Here, it tells them where to upload the documents. It tells them bank-to-bank accounts and details or the managed phones are actually scanned by Amazon, and it will tell them that it is a secure process and an upload. The first thing that they have to do is click on browse. When they click on browse, they will choose a social security or a credit card. They will upload the software and it will tell them AWS secure process and upload. The person will click on this link. It will say encrypting and uploading. And then you will have a message from the website saying it got updated. Here it says success. File has been secured in S3 and queue for Macy's scan. We can also see that all the data that has been uploaded is showing here. We can see that on December 15 or December 14, the credit card information has been uploaded and is clean. And you can see that the data and including the time has been uploaded and is clean. It also shows them the message that the update has been completed for them to understand that this has been completed. It also provides the compliance terms, right? Which allows them to understand why we're doing this and why it has to be this way to make sure that SOC 2 is compliant and ISO 27. When the person logouts from the screen, they have in the left side the logout screen. We can also see that if anybody uses an incorrect password or an incorrect name, they will have access denied. So only the authorized users are available to log in into the website. Now I'm gonna go over the upload that we just did in S3 to make sure that the data is here. We can see here that the data has been already set up in the S bucket or in the financial bucket that we created. And here we can see that all the data has been successfully updated. Here you can see that the social security information, the credit card that we sent, is actually in the bucket. And from here, we can access the information by going into the data and successfully seeing it here. As the file gets downloaded, we can see here the credit cards files. Here, as soon as you open it, you will see all the data, meaning that the data imported or uploaded into the portal was scanned by Macy, make sure that it was nice and updated, and now we're able to download it from the AWS portal into the S3 bucket to make sure that the infrastructure team can upload the correct information into the portal for the user to log in for the first time into the platform. I have demonstrated today a minimum viable product. However, for an enterprise rollout, I will do few things. First, the high availability. I will place a load balancer in front of the server and use auto-scaling groups to launch more traffic or more servers during high period traffic. The next one will be as the data is currently pulled live from S3, I will switch to a database into Amazon DynamoDB. This in order to scale into millions of files. Thank you for your view. Bye bye.